Hi, this is Joana Shepard, and I will be doing my presentation on the planet Jupiter. So this is our solar system. We are part of the Milky Way galaxy, and we have 8 planets and 9 known dwarf planets, although more are being discovered all the time. So a little history about Jupiter. It was discovered in 1610 by Galileo Galilei. He would go out and study the stars with his telescope. He saw these 4 moons, and when he saw them, he rocked the astronomy world at the time. We had these ancient Greeks and astronomers such as Aristotle who believed firmly in the idea that God created the earth to be perfect and that it was the center of the universe, and all the other planets, suns, stars, moons revolved around it. This was So there's a model of it right there. The earth is the center with everything going around it. In 1514, Copernicus was the first person to create the heliocentric model, which was the idea that the sun was the universe center. But he was fearful of the church condemning him, and he waited until 1 year before his death in 1542 to make that theory public. That is what that looks like. Galileo was actually arrested for his radical ideas when he confirmed the heliocentric theory. And Kepler, around that same time, further refined it and created the model which we know today to be true. Galileo had, and all of those older astronomers hundreds of years ago. We have telescopes and satellites and spacecraft so we can get more detailed information. So today we know that Jupiter is the largest planet. It's 2.5 times more massive than all the other planets combined. If Earth was the size of a nickel, Jupiter would be a basketball. It could have become a star if it had more mass, but it needed about twice as much mass as it has now. So instead we get the large gas giant that it is. It has a diameter of about 143 kilometers, which is about 89,000 miles. And one day on Jupiter lasts about 10 hours, which is the shortest day in our solar system. The gas giant, you can see a picture there. Most of these pictures are from NASA.com. Jupiter is known as the gas giant. It consists of mostly hydrogen and helium, which is very similar to the composition of the Sun. There is no true surface to Jupiter. It is mostly swirling liquids and gases. However, it is thought to have a solid core because it has a spherical shape. And if it was truly all gas, the rapid rotation would flatten it. But this rapid rotation combined with the lack of solid surface makes the poles move slower than the equator, and this creates a bulging effect at the equator, a flattening effect at the poles, and it affects the day length. So the poles have a shorter day than the equator does. And in our textbook, Professor Brackney describes this shape and movement to a spinning water balloon, where if you spun it fast enough, it would contort and then kind of spring back together. Jupiter is an angry planet. It has a hostile environment of storms and currents, electrical charges, noxious gas. It's pretty poisonous. The clouds are made of mostly ammonia crystals. They're pretty thin, and then there are bands of darker gas, which are compounds that have been brought up from the center. So plumes of sulfur, phosphorus gas get heated up by the internal heat, and then they come up to the surface, swirl around with the clouds, and change sunlight or change color due to sunlight. So Pioneer 10 and 11 are spacecrafts that found evidence that the planet itself is composed of almost entirely liquid hydrogen, which is creating an ocean beneath the surface of hydrogen. And it's actually the largest ocean in the solar system, according to weather.gov. Scientists think that as you go deeper into that hydrogen ocean, the pressure increases and squeezes the hydrogen atoms, dispelling electrons, which then charges the liquid into a conductive like metal. And as you go deeper and deeper, that may become solid. So the Great Red Spot, that's the most easily identifiable feature of Jupiter. It dates all the way back to the 17th century, where it was observed by Robert Hooke, and then it was identified later in 1665 by an Italian astronomer, Giovanni Cassini. So scientists believed it to be a giant storm, and that is indeed what it is. It is 2 times larger than Earth, measures approximately 24,000 kilometers in diameter and 14,000 kilometers in height. But it is shrinking as time goes on. When it was first identified, it was about 40,000 kilometers estimated in size, and now it's about half of that. Astronomers don't know if it will ever disappear, but they believe that if it does, it's just going to reappear somewhere else. And it will continue raging. It's been raging on for at least 150 years that they know of. So we talked about Jupiter has a large magnetic field. That magnetic field creates the Jovian magnetosphere, which is a large area of space affected by that magnetic field of Jupiter. And it stretches all the way out towards the sun about 2 million miles and all the way back towards Saturn about 600 million miles. And that magnetic field on Jupiter is about 54 times that of the Earth's. And it rotates with the Earth and sweeps up all electrically charged particles and traps them in little bundles or swarms. And then it accelerates them as it continues to spin and brings them up to extreme energy. And when you put those two together, it creates intense radiation that shoots out at all the closest moons, and that creates a really hazardous environment, so no spacecraft can fly through there to study Jupiter closer because they would be damaged. But it also creates these beautiful aurora lights at the poles of Jupiter, and there is a link here to a video of those if you are interested. Uh, they believe there is a core, but it's actually unknown. So most of this is going off of theory. So they believe that it has a rocky, icy surface, and this is based mostly on planetary formation. And what we know about it. And that means that there has to be some sort of a core in order to have it tracked and sucked up all these gases that it would have taken to create such a giant. But it also could be a super hot dense soup. So we are just not sure. We do know that they have a very high temperature inside of Jupiter there, 90,000 degrees Fahrenheit. May contain iron and silicate materials like quartz. Right now, there's currently a spacecraft, the Juno mission, which is orbiting Jupiter and continuing to update and give more information. So if you're ever interested, you can go to the NASA website and look up all of this information. There are also rings around Jupiter. Which is a surprise to some of you, I'm sure. In 1979, NASA sent Voyager 1 out into space, and it discovered the rings of Jupiter. But we find that they're hard to see because it's mostly small, dark particles, and you can only see them when they're backlit by the sun. There are 3 parts of the ring system there. The innermost halo, The middle is the main ring, and then the outermost is the Gossamer ring. And the location of the rings coincides with the location of the moons, which created and confirmed a theory on how the rings were formed, that it was pulling the dust off of those moons. So that brings us to Jupiter's moons. So Jupiter has 79 moons and acts as its own miniature solar system. We're obviously not going to talk about all 79 of the moons, but we will talk about the main four. The first one is Io, which is a very volcanically active moon. Ganymede, which is the largest of the moons. Europa, which is the most well-known and the third smallest moon, which is a big icy block, and Callisto, which is more rocky. So this is Io. This is the third largest moon. It is 423 miles, or kilometers rather, from Jupiter, and is the most volcanically active body in the solar system with over 100 active volcanoes. It has powerful electronic currents and creates lightning on Jupiter. So Jupiter actually sends energy to Io and generates an electric current of 400,000 volts and 300 million amps, and then Io sends it back to Jupiter and creates that outer atmosphere lightning. The rapid rotation of Jupiter whips the radiation around with it and strips 1 ton of material off of Io every second. And all of the volcanoes on Io help to replace that surface material and fill in any craters from any asteroids or meteors or anything like that. The composition of the lava on Io is not entirely known, but it is believed to be molten sulfur or compounds and silicate rock. And then it has a thin sulfur dioxide atmosphere around it, as well as its own magnetic field, which may be an indicator that it has an iron core at the center. Europa. So Europa is probably the most famous moon. It's the smallest of all the moons, but it has the most likelihood to host some kind of life outside of Earth. It is 666 kilometers from Jupiter and is an icy surface. The surface is about 24 kilometers thick and is most likely thought to sit atop a saltwater ocean, which is actually twice the amount of water than there is on Earth. It's estimated at about 40 to 100 miles deep, and also thought to have a rocky mantle or iron core, which is similar to Earth. The icy surface has visible cracks all over, creating pattern, and scientists think that water is shot out through plumes into space, and that if a spacecraft went through, that it could collect samples of the water and learn more about what is truly beneath that surface. The next moon we'll talk about is Ganymede. It is the largest moon in the entire solar system. It has its own magnetic field. The planet is made of 3 layers. The core is a metallic iron. The mantle is a rocky shell. And then the surface is made of ice, but scientists also believe it has rocks mixed in due to some bulging that they see happening. The surface is made of darker, older material and lighter, younger material. So the darker, older material is heavily cratered from asteroids and being pelted, and then there's younger material with grooves and ridges that they believe is some faulting or water rising to the surface. And the atmosphere has a thin layer of oxygen. And the last moon, Callisto, which is the second largest moon of Jupiter, is heavily cratered and was thought to be a dead moon until recently. They discovered it may have a saltwater ocean, deep, 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 deep down, over 100 miles deep into the moon. It is the furthest away from Jupiter of the Galilean moons and may contain a thin carbon dioxide atmosphere. And a list of my cited pages. Thank you.